Good morning. My name is Sheikh Siraj. I am from EC department. Here, my roll number is there 21951804J2. So today I am explaining about tridiagonal matrix. First of all, we want to know about banded matrix. A banded matrix is where matrix whose non-zeros entries are confident to a diagonal band comprising the main diagonal and zero or more diagonals on either side. So here we are seeing that matrix, two matrix, 3 by 3 matrix, 3 by 3. Here banded matrix. The matrix can be symmetric having the same number of sub and super diagonals. If a matrix has only one sub and one sub super diagonal, we have to tridiagonal matrix, etc. The number of super diagonals is called the upper bandwidth 2 in the example, and the number of subdiagonals is the lower bandwidth 3 in the example. The total number of diagonals 6 in the example is the bandwidth. Here we are seeing this number of rows 1, 2, 3, 4, 5, 6, and number of columns 6. What is a tridiagonal matrix? A tridiagonal matrix is a band matrix that has non-zeros elements only on the main diagonal, the first diagonal below this, and the first diagonal above the main diagonal. So here this considering as a 4x4 matrix. Here A1 B1 0 0 C2, this is a this like, and 1 4 3 3. Here A1 A2 A3 A4, this like tridiagonal matrix algorithm. Thomas algorithm, also called tridiagonal matrix algorithm, TDMA, is essentially the result of applying Gaussian eliminations to the tridiagonal system of equation. A system of simulation algebraic equation with non-zeros coefficients only on the main diagonal, the lower diagonal, and the upper diagonal is called a trigonal system of equation. Generalizing trigonal matrix. Consider a tridiagonal system of an equation with n known as u1, u2, so u3, so on un as given below. So here we seeing that rows like columns example this. So generalizing tridiagonal matrix, note A1 is equal to 0 and Cn is equal to 0. So the matrix can be written as AI ui minus 1 plus bi ui plus ci ui plus 1 is equal to di. So looking at the system of equation, we see that ith unknown can be expressed as a function of I plus 1th term. Unknown, that is u is equals to yi ui plus 1 plus pi. Ui minus 1 is equals to ui minus 1 ui plus pi minus 1. Here, let's solve a problem for clear understand. So here this is a problem. Let us consider the system of equation. Given that 3x1 minus x2 plus 0x3 is equals to minus 1. Okay. Minus x plus 3x minus x3 is equals to 7. X0 x1 minus x2 plus 3x3 is equals to 7. Matrix form is this like. Understand? The numbers are written as like this, and the x1 x2 x3 is written as column and it is given is equals to -177. This is numbers. One, these numbers are, understand how it is right. Now here stage 1 converting mx is equals to rho into ux is equals to p. Rho 1 3x1 minus x2 is equals to -1. Divide the equation by a1. In this case a1 is equals to 3. x1 minus 1 by 3, x2 minus 1 by 3. Assuming the coefficient of x2 as y1 and the remaining constant as p1. Now the equation converts to x1 plus y1 x2 is equals to p1. P1 taking P1 is equals to -1 by 3, Y1 is equals to -1 by 3. Okay. After changing rows 1, we are changing row 1. Okay. Converting mx is equals to raw r means into ux is equals to p. Row 2 multiplying a2 minus 1 in row 1 and eliminating x1 row 2. Row 2 is here x minus x1 plus 3x2 minus x3 is equals to 7. A2x row 1 we know that. Subtracting right here x2 this equation becomes as. So here we are finding y2 and p2 this including like after changing row we also now here changing the row and now we are finding row 3 multiplying a3 same process previous process. Here's we are taking row 3 and x3 is equal to 7 plus p2 so by 3 plus y2 p3 is point we are finding that x3. So here also we changing after row 3 this likes appearing. Okay. Now stage 2 backward substitution. Here we row 2 and x3 plus substitution this same previous row 1 and this solution is here. Why Thomas algorithms is used? This type of a computation is quick trigonal system of equation are most common. Even most of them convert the general system of equation to tridiagonal system of equation. Its importance is clearly visible with a large number of unknowns. Limitation of Thomas algorithm. Algorithm is unstable when bi minus ai yi minus 1 is equal to 0. This occurs if the trigonal matrix is singular and in some cases non-singular also. So singular matrix determinant is 0 square matrix. It does not have a inverse. So A is equals to this is the example of matrix. Non-singular matrix determination is non-zero square matrix. It has a inverse. Here also given example taken A is equals to condition for algorithm to be stable. B mod bi and ai. This is for every I. It's what can be done when the algorithm is numerically unstable, providing maths. This condition for algorithm to be stable. Here appearing. So this is the information about trigonal matrix. Okay. Thank you. Thank you.